Hello everyone, welcome to my YouTube channel. So in this video we're going to consider the concept of derivatives of logarithmic functions. Alright, so there are two types of logarithmic functions to be considered. A logarithmic function where we have a base of the Euler number. This E is called the Euler number. Now when you have a function of this form, a logarithmic function where the base is this Euler number, and we can actually write it as ln, is also called the natural logarithm. So where x cannot be 0, so we say that the derivative is 1 over x. So if this x now becomes another function, so you will now apply the function of function rule, that's the chain rule. Alright, and then we are saying, what if the base is not the Euler number, that's is not e, is not 0, and is not 1, and is any other number? So how do you get your derivative? We also said that of course all of these are standard derivatives, and we can show the proof for this, okay, and then from here we can get this. Okay, so now this one we said is equal to 1 all over x multiplied by ln a. Okay, or you can say 1 over x multiplied by log ea. Of course this is exactly equal to this because if from here you can see that we said that our ln a, remember ln we said is equal to log x base e here, so that means this is actually log a base e. Okay, so if you bring this up now, you are going to have 1 over x multiplied by 1 all over log a base e, and you remember the rule of change of base in logarithm, so this is actually the same thing as log e base a, so this is actually the same thing as this, so any of them. All right, so we'll take some examples quickly. Now first we have examples here. It says differentiate the following with respect to x. So we begin with the first one. So here we are given the ln of x plus 1. Okay, so as our y. So this is the y, and remember this is a function. That means you're having a function of function. Okay, so that is to say that we can call what you have inside u, x plus 1 is our u, and if x plus 1 is u, it means that our y now is the ln of u. If that happens, so it means that we can find our du. Our du will be equal to, du with respect to x will be equal to 1 if you differentiate this, and while dy with respect to u, so if you now differentiate y with respect to u, which is this one, you are going to get by what we said initially, 1 all over u. So that means that our dy dx, which is equal to dy with respect to u multiplied by du with respect to x. Alright, so if you substitute here, then we are going to have 1 all over u multiplied by 1, which is du dx, and that is going to give you your solution as 1 all over u, whereas we know that our u is 1 x plus 1, and so this is your derivative. Okay, so for example 2, we are going to have that our y is equal to log base e of sine x, and remember what we said log base e is always better to write it as ln, so which is ln of sine x. Okay, and like I did earlier, here our u, let it be sine x because this is a function of function, and if it is sine x, it means that du dx is equal to cos x. And so if u is now sine x, therefore our y will be what? Ln u, and immediately dy du will be equal to 1 all over u. So that implies that our dy dx by chain rule is equal to dy du dot du dx. Okay, so what is our dy du? 1 over u multiplied by du dx, which is cos x, and this is going to give you cos x all over u. And what is u? Our u is simply sine x, so you have cos x all over sine x. And you recall that by trigonometric function, that cos x over sine x is actually equal to cot x. Therefore, our dy dx is the same thing as cot x. All right, and that's the solution. We go to example 3. Example 3 says that our y is equal to the log of 10, 3 plus x raised to power 4. Okay, so here this is a function of function. Now in this case, our base is not e, our base is a normal number, so which is what we represented with a here. Okay, what we represented with a in this case. A here represents any other constant except e and 1. Okay, so let's go. So for this now, what do we do here? So we recall that, of course, we are going to give a name to our u here. So that means our u is going to be x raised 3 plus x raised to power 4, which implies that du dx is equal to 4x raised to power 3. Of course, this is going to be 0. And then our y will now be equal to log u base 10. And so when you differentiate log u base 10, what are you going to have? So dy du is going to be equal to, from that relation, we said that it's equal to 1 all over 1 all over u multiplied by the length of the base, and in this case the base is 10. Okay, so that means that our dy dx, so our dy dx here is going to be equal to, by chain rule, of course you remember why this is over u, because you have u here. In this case here we had x. Okay, so we had x here, so you had 1 all over x, and you're differentiating with respect to x. So the same thing is applicable here. Since you have u here, so and you're differentiating with respect to u, it will be 1 all over u, then multiplied by the length of the base. Okay, and so this is going to give us our dy du is this, which is 1 all over u ln 10, then multiply by du dx, and du dx is 4x raised to power 3. So if you multiply this, we are going to have 4x raised to power 3 all over u. And what is our u? Our u is this, which is 3 plus x raised to power 4, then multiplied by the length of 10. And that is our solution. Okay, and so the next one, we have example 4. And so being a product, it means that this is our u and this is our v. And recall the formula, u dv plus v du. Okay, so that means our dy dx is going to be equal to u, which is x squared, multiplied by dv, and v is ln x, and when you differentiate ln x, you get 1 all over x, then plus v, and our v is that ln x, multiplied by du, the differentiation of x squared, which is 2x. Okay, and so from there we are going to have, yeah, this will take away this, so we have x left there, plus, of course, this multiplying this will give you 2x ln of x. And because we cannot do anything further here, this becomes our solution. Okay, and finally we have ln x all over 1 minus 2x, which is a quotient. So that's going to give us, so this is our u and this is our v. Okay, so recall the formula for quotient, v du. So if we substitute into that formula, it means that our dy dx is going to be equal to v is 1 minus 2x multiplied by du. Du is the ln of differentiation of ln x, which is 1 all over x, then minus ln of x, which is u, multiplied by differentiation of this, which is minus 2, and that is all over the square of 1 minus 2x. Okay, and so if you simplify this, you are going to have 1 minus 2x all over x. Then this multiplying this will give you plus 2 ln x, and that is over, and of course, yeah, the much you can do here is to find a way to bring down this x below, which we can actually do, and that is going to give us 1 minus 2x plus, so here now x is going to multiply this, and that will give us 2x ln x all over x, then everything over 1 minus 2x all squared. And so if we decide to now bring down the x to become a denominator, we are going to have, so, and that's our solution. Okay, and that's where we are going to stop for this video. Kindly take a look at the whole process, and please subscribe to our YouTube channel, like and share our YouTube videos, and we'll see you in our next video. Bye.